So this is another day of review for your final, and I gave the kids this polar point. It was right there, and it was at 3. This is r comma theta, 3 comma 3 pi over 4. And I said, find me a whole bunch of other ways to say that. Like, for instance, 3 comma, and instead of 3 pi over 4, maybe make it go all the way around and back to here, which would add 2 pi to it. So that would be 3 comma 11 pi over 4. How many of you had that one on your list? Excellent. Cooper, can you tell me another one that you found? Okay, let's do one more with a positive angle. There was one more, no, a positive r, but a negative angle. Did you have any that had a negative angle? Negative 5 pi over 4, there we go. That was the one with a positive r and a negative theta. Then we get into the shadow point. Over here somewhere, there's a point that is related, but not this same as this point. And it helps you find negative 3 comma, and what's this one? I would call it negative pi over 4. And last but not least, negative 3 comma, you could get to this point by going that way, which would be 7 pi over 4. There's even more ways than that, but those are all ones you'd be expected to know for your final. Okay, then I gave you this problem. R equals 5 cosine theta. And I said, translate it from polar into the only other system that we know how to translate it to, which is called rectangular. How many of you knew you needed to times by r on both sides? Raise your hand if you remembered that. Okay. If you didn't, I need to maybe give you a reason to care. Well, you might be like, it's on the final. Well, I don't care. I've just burned out at this point, Mr. Server. Well, if you can force yourself to just do a couple more days of math, it could make a big difference to you in math. Why? Because a lot of you are at like an A- right now. Very few of you will go up with the final. But a fair number of kids at this point in the year give up and they're like, I'm just too tired. I just can't do it anymore. And they don't study for their final and then they drop. And that's the way it goes. And if you're right here at an A-, very few can pull it off to bring themselves up to a straight A. It's part of the nature too, is to get from an A- to a straight A, of course you have to have an A on the final. You probably have to get 100% on the final, and you have to probably turn in a whole bunch of late work and redo your top 20, and that's a lot of work, and a lot of kids aren't willing to do that. So I get very few of you are going to move up. But what I mostly want to do is say study so that you don't move down. It's really depressing. It happens. Kids just kind of let go, and they're like, screw it. I'll just get wherever I get. And you get a C on the final. And then all of a sudden, you'll go from an A- 2 down to a B+. All right, so take it seriously. Finals one test you can't retake. All right, so that was a couple problems off of polar, and now I want to give you a lot of freedom to ask me questions. Last hour, I wanted to ask me questions about graphing, so I did some of those. Maybe you'd like some help on that. I don't know, what topics do you want to know? Vivian, you're first. And you guys get to judge. She's going to tell us a problem number from the packet, because I don't want you guys coming up with crazy things that are not on the packet. Find me something from the packet, because we all have the packet, and then we'll all turn to that problem. And if you feel completely confident, well, you can just ignore this explanation and work on other things. All right, which one do you want to talk about?
The second one on 26.
26, the second part. All right. That one says inverse cosine of secant of pi. All right. How about this, Vivian? Where do you start on this problem?
You have to start in the parentheses.
Correct. So if we can draw this situation for secant of pi, that would be really good. So do you know where we go to draw that? Hint, it's one of the spots that's called a quadrantal.
I don't.
Okay, so pi is right here. And you've never seen me draw a triangle out of a straight line like that. So that one, you can't draw a triangle for. So I'm going to start by making a point for that. For the quadrantals, you have to memorize all these points. This one's -1, 0. Are you with me so far?
Yep.
All right. So now, do you get that deal where sine was y and cosine was x and tangent was y over x? Okay. Now, what the heck is secant? Remember that secant is one of the ones where I said, instead of doing secant, do something else and then flip it.
It's cosine.
So cosine is really x, right? So act like this thing said cosine of pi, and then the answer would be -1. How do you flip the answer of -1? Well, it's -1 over 1. Do you get when I flip it, I actually end up with the exact same thing?
Yeah.
Yeah, -1 over 1, and I flip it, it's still -1, isn't it? Now, I have to do inverse cosine of that. Remember, that's asking me for an angle. Okay? So what angle is it that gives us an answer of -1? I'm going to just rewrite the problem now. It says inverse cosine of -1. That's like this. That's like cosine of some angle is supposed to give me -1. Why do I rewrite it that way? Because it's really hard to know what they want here. And this is a rewrite of it that shows me, oh, I guess I'm supposed to give an angle. So what is the angle?
I was gonna ask about earlier when you did the secant thing.
Yep.
Isn't it supposed to be flipped because secant equals it's like the -1?
Do you flip the angle? No. Okay, so you flip the answer to the problem. So we have never flipped the angle. That's not a thing. But we flip the answer to it. So how about if I write this out and say secant of pi is equal to, I don't know what it's equal to, so that's the point. That's what I'm trying to find, okay? And I now say, okay, wait a minute. I want to actually do 1 over secant, which is actually the opposite of, not the opposite, it's the sister function of secant, which is cosine. So cosine of pi, notice I didn't flip the angle. I flipped the answer to it. That's why our -1 ends up flipping over, but yet this is one of those weird ones when you flip it and it doesn't actually change the answer. All right, so bottom line, can you trust me that the answer comes out to -1? All right, then I rewrite it to this, and then I rewrite it to this, but there is technically a difference. It's just that this one was an inverse trig question, which means you can only have one answer, and the answer has to be from here to here, but the answer is in that range, right? It's right there. So there's the answer. I know, tricky. I'm glad you asked. So are there any others off the packet that you'd like to talk through? Yes, sir.
Number 24.
24, everybody look at problem 24. So, on this one, I want to give you this formula again. A cosine of B times x minus C plus D. Since you asked about it, I'd strongly recommend you take notes on it. So write this out, and then I'll remind you what each of these things is. This is the amplitude. And you get that from looking at your graph and seeing like what the highest and the lowest points were. The easiest way when you have one of these graphs that's going up and down and up and down and up and down like this is finding the center line that runs through it. And the amplitude is this distance right there. The amplitude is from the center line up. Okay. The B, the thing I want you to remember there is that the period is 2 pi over B. So sometimes we give you the period, which is like on a Ferris wheel, it's how long it takes for the Ferris wheel to go all the way around. So it's time. Okay, so they'll give you this, and therefore you can figure out what B is by solving. Once they tell you the period is, let's say they tell you it takes 10 minutes for the Ferris wheel to go around, you put a 10 there, and then you solve for B that way. This is the X value of the first peak. And last is that is the center line. It's like that line. That's how far up it's been shifted. So there's your little guide to doing problems like this. So I know it's a Ferris wheel and you're like, what exactly do I do in all these spots? The first thing I'd try to do is figure out like the period. That's probably going to be the hardest part. And then I'd solve for B. The second thing I'd try to do is figure out this dotted line that runs down the middle. Like how far is the highest and the lowest spots that you'll ever be on this Ferris wheel. And then you'll be able to average them and find the center line. By finding the center line, you're getting D, and you can figure out the amplitude from the center line. So those are the two biggest things. Why don't you take it from there and try. Remember, of course, we've got a key. And I hope together with this explanation, the key and that is enough. Because I don't want to do the whole problem for you. Otherwise, you could just look at the key for that. Okay, yes?
Could you do question 27?
I will at least help you with question 27 for sure. All right, so on 27, it's a very good one. It's, what if I just asked you, what's the difference between what 27 says and this? Like, look at this, look at 27. There's only one difference. What's that one difference?
So you have to use a different formula, right?
Nope. Just look at the problem. Look at the problem, 27. Look at my problem.
So it's 2 theta?
Exactly. So here's my best tip. Do it like it's this. Act like it's this, and only at the end, put in the 2. Okay? So another way to say it is, I would take this and I would go, let's replace this with u. And then it's cosine of u equals -1/2. So you do it just like a normal circle trig question. You go, where's cosine negative? Students take calc. Cosine's negative over in these 2 quadrants. So I'm going to cross off these 2. Next, where is, of those spots, do I rule any out? No, I do both answers. Okay, so I'm going to get 2 answers. But wait, do you remember that this had a 2 actually here? That means that at the end I'm going to have 4 answers. You remember how the number here doubles how many answers we would have? If you have a number right there, it's going to double how many answers we have. So first we got to find these 2 answers, and then we will double them. So then you draw yourself little triangles here, and you get those answers. And let's actually have you do that. Tell me, cosine's adjacent over hypotenuse. Tell me what to do now. Oh, voice got froggy. I'll come back to you after your voice goes back to normal. This is root 3. And then I'd go across from the root 3. I know what that is. What's across from the root 3 is a 60. That's also known as a pi over 3. So my answers are actually 2 pi over 3 and 4 pi over 3. But, this is the big but, that was if it was just a u here. So u equaled 2 pi over 3 and u equaled 4 pi over 3. But then do you remember the little dance we have to do where we have to replace the u with, what was u really at the beginning of the problem? What was this? Okay, it was really, it was, okay, I understand. It's happened to me earlier today. That is actually a 2 theta. So then I put a 2 theta here. Do you remember this part? Do you remember doing these? Okay, you may, if this feels like it's all new to you, maybe you were absent the days when we did this in class and you want to go back and watch the review video because it took a whole day to explain this to everybody. So this is the part where I'm just going to review it briefly. Then you got to remember to add plus 2 pi k here and plus 2 pi k here. And then you have to multiply everything by a 1/2 to get rid of that 2. So a 1/2 here and a 1/2 here and a 1/2 here and a 1/2 here and a 1/2 here. And then, remember how I said there was going to be 4 answers? These are going to be 2 of your answers. The other 2 answers you get by adding in, if I put in k equals 0, this part just disappears. If I put in a k equals 1 on both of these, k equals 1, then I can get my other 2 answers. And I know I didn't completely cover that as well as you would have wanted, but frankly, it's a 1-hour lesson and you don't have time for that. So if you want me to walk you through the rest of it one-on-one, you can come up and ask, but at least have this much done. All right. Are there any other topics that you haven't, like you'd like a little extra explanation besides what the key says? Vectors is fairly recent, so I'm imagining that that part will go well, but parametrics also fairly recent. The parametric thing was where there's always an x equation and a y equation, and there was always a t limiter, that kind of thing. All right, well, I don't want to make you listen to me. That's a waste of time. So this is the part where I'll give you time, and you can always come up and ask me for help. And yeah, this needs to be you need to take the initiative and go, dang, don't know how to do that. Gonna go look at the key quick. Oh yeah, that brought it back to mind. Or, I still don't get it. Walk up and ask me for help. All right, that's all I've got for you for the video for today. We will have another full day of review on Monday, and then the finals actually start Tuesday, Wednesday, and Thursday.